Hi everyone, welcome to the Optimizing Resource Efficiency session. I'm Mariana Tashenko and I'm a Senior Technical Product Manager working out of our New York City office and on Compute Optimizer.
Hey everybody, I'm Le Tian Feng. I'm a Principal Product Manager working on Compute Optimizer.
This is actually my first reInvent and I'm really excited to be here. Is this anybody else's first reInvent? Show of hands. Okay, so quite a few new faces, so welcome and welcome back to those who've been here before. I'm excited to walk you through what resource efficiency is, how to optimize it, and how Compute Optimizer can help you do this across your workloads. So here's a sneak peek into our agenda. We'll start at a high level talking about what resource efficiency is, what right sizing is, and then we'll dive into Compute Optimizer, including how it works, and some new features that we launched. One of which came out in August, and two of which we actually launched just this week at reInvent. So let's talk about what resource optimization is to level set. So resource optimization involves ensuring that your resources have the right configuration based on your goals and best practices. And there are two main types of resource level optimization, each of which is important and contributes to overall resource efficiency. So the right resource configuration will optimize for cost and performance. So when I talk about cost, what do I mean? I mean maximizing the value you derive from your spend, or minimizing the costs that you incur to achieve your performance goals. When I talk about performance optimization, what I mean is ensuring that your workloads aren't bottlenecked or at risk of being bottlenecked so that your end users can have a good experience. Compute Optimizer supports the first two with resource right-sizing recommendations. And in the following slides, we'll talk about how that is. So let's talk about what right-sizing is first. You can achieve resource efficiency across both cost and performance through right-sizing. And we'll dive into what right-sizing is, and then that will tee up our conversation about how Compute Optimizer can help you maximize cost and performance efficiency through right-sizing. So right-sizing is the process by which you configure or reconfigure resources to maximize savings while meeting performance requirements. This means that right-sizing needs to consider not only your current spend, the cost of your resources, but also your workload needs historically and in the future. This is an important process for any organization, and especially growing organizations. It can help you run your workloads more efficiently so that you can scale faster. And I won't downplay the fact that right-sizing can be challenging. Can you think of any workloads that may have had cost or performance improvement opportunities that you didn't take advantage of, and why that might be? I'll name a few reasons that I've heard. Number one, it can take time to evaluate the resources within a workload and determine whether there is an opportunity to reduce waste, recoup cost, or if there's a potential resource bottleneck risk there. Number two, AWS offers a vast library of products, services, and features. And it may not be easy to, without some significant expertise, determine what is the right resource to use for a particular use case or workload. Third, it can be difficult to understand the estimated impact of a right-sizing configuration change. So it could be that you might recoup a lot of cost and have a significant performance improvement opportunity through a right-sizing activity, or it could be minimal and maybe not worth the engineering bandwidth. So this is where Compute Optimizer comes in. So Compute Optimizer is a right-sizing recommendation service, and it delivers recommendations across 4 resource types today. So that's EC2 instances, auto-scaling groups, Lambda functions, and EBS volumes. It analyzes the configuration of your current resources, as well as the utilization metrics, and generates recommendations for more optimal configurations considering both cost and performance. By default, the service is free, and it analyzes the last 14 days of your CloudWatch metrics. When you opt in to Compute Optimizer, the service starts to evaluate your CloudWatch metrics over the past 14 days, and evaluate whether the resources are under-provisioned, over-provisioned, or optimized. And depending on the finding, specifically if it's over-provisioned or under-provisioned, Compute Optimizer will generate recommendations at a resource level that tell you what is a better option for that resource from a cost and performance standpoint. And then we take you to the console where you can actually implement the change, for example, the EC2 console. So you might wonder why Compute Optimizer is the right choice. And we'll talk in more detail in the following section about how Compute Optimizer works and give some examples. But at a high level, customers should use Compute Optimizer to eliminate the challenges that I mentioned associated with right-sizing. It reduces the undifferentiated heavy lifting that you need to do to maximize your cost and performance efficiency. So before handing it over to Lei-Tian to talk about how Compute Optimizer works and give some examples, I'll just highlight the benefits to keep in mind. So number one, smart recommendations based on insights generated by an ML-powered recommendation generation engine. Two, continuous metrics analysis and optimization recommendations. So we refresh recommendations often so that you're able to have up-to-date configuration recommendations. Third, engineering time and bandwidth savings. So engineers can spend less time finding resource optimizations and more time on their core competencies like operational improvements and feature work. Fourth, reduce cognitive load in choosing among a large library of resources. Compute Optimizer does it for you, so you can focus on the core competencies I referenced. And finally, central cloud managers can spend less time mining for savings opportunities across an organization. And with that, I'll hand it over to Lei-Tian.
All right, thank you very much, Mariana. So I'd like to talk a little bit about how Compute Optimizer works. So I'm going to talk about some high-level concepts, and then I will actually do a demo to show you recommendations in action. So at a high level, Compute Optimizer generates recommendations in 3 steps. So first of all, it analyzes whether your resource meets the performance requirements of your workload. And by performance requirements, I really mean that Compute Optimizer detects whether your current resource is being throttled on various limits like CPU limits, memory limits, network limits. And if it's being throttled, then Compute Optimizer will say your resource is under provision. It will look for some bigger instances for your workload. For other instances that the resources are not being throttled, then Compute Optimizer will actually look for some alternative resources that are actually smaller than the current one, and find out that if there's a smaller viable options that can also meet the performance requirements of a workload. And if so, then it means that you have a cheaper option available, then your resource is over-provisioned. Otherwise, then if you're already using the smallest options available, then your resource is optimized. So after doing all this kind of analysis, Compute Optimizer forms opinion about resource and tells you what the recommendation is. And then together with the recommendation, it gives you a couple of other additional informations. Things like estimated monthly savings, price difference, and project utilization metrics, so that you can analyze these important information alongside which instance type you should be using. And these recommendations are refreshed daily. So on one side, having recommendations is very important because that's the reason why you use Compute Optimizer. But on the other side, being able to easily access recommendation is also equally important. So let's talk about how you can interact with Compute Optimizer. So as a service, it goes without saying that Compute Optimizer recommendations are available through the Compute Optimizer consoles and APIs. But there are also a lot of other places you can get these recommendations. So let's just name a few. So first of all, Compute Optimizer is integrated with Cost Explorer via the right-sizing recommendation tools. If you go to Cost Explorer console, on the left navigation, there is a right-sizing item. You click on the item, these recommendations come from Compute Optimizer. Secondly, you can go to the EC2 console. When you select the instance, at the bottom, you will see there's Compute Optimizer recommendation and tell you whether the instance is optimized or not. So it allows you to actually look at the recommendations while working on EC2 instances. So that's a nice integration we have done, and it's been quite popular. Third, Compute Optimizer is also integrated with AWS Systems Manager. So you can have your operations data and recommendations data side by side in Systems Manager Explorer. And lastly, we allow you to export recommendations as CSVs to S3 bucket. So a lot of customers, they may have like internal workflows to draw dashboards, like put things in database and run reports. And exporting the recommendation to S3 bucket is a particularly useful features for that. So for EC2 instances, we look at metrics from 4 different dimensions. The first one is CPU utilization. The second one is memory utilization. For memory, the metric's not available by default, so you will need to install CloudWatch agent so that you can collect these memory metrics and publish it to a special CloudWatch namespace. And then the third one is network performance metrics. For network, we analyze 2 types of metrics. One is the bandwidth consumption, and then another one is the PPS, the package per second. So there are the separate limits, and we analyze both. And the last one is the storage. So there are 2 types of storage. One is the local storage. The physical hard drives, SSDs, and HDDs attached. They're physically located in an instance. And then there's also Amazon EBS volumes that are remotely attached to the instance. And we analyze the IOPS throughput information of both EBS and local storage. So here's example recommendation. For example, you're using M5 2X large that has 8 vCPUs, 32 gig of RAM. And you pretty much have 40% CPU utilization during the day and 10% CPU utilization during the night. The memory is pretty much like 30%, and you have very low network and storage utilization. So I received a lot of questions asking, like, does Compute Optimizer analyze this maximum utilizations or average utilizations? We actually analyze the patterns of the utilization. So, for example, if your workload is running 100% CPU during the day, 0 CPU during the night, the average is 50%. But 50% is obviously not reflective of the workload you're running, right? Maybe 100 is more reflective, but we kind of analyze the pattern to find out, like, what period of time are your workloads busy, and we try to size based on the busy period to make sure that there's no additional performance risk being introduced by these recommendations. So for this particular examples, we have 3 options. The first option is M5X large, which is one size smaller than the current one. You have 4 vCPUs, you have 16 gig of RAM, you're going to save 50%, and your performance risk is pretty low. The second option is actually using T3, which is a burstable instance. You can save a little bit more, 57% based on on-demand price. But there's a little bit of risk because T instances is CPU oversubscribed instances. And the third option is you can actually reduce the number of vCPUs by another half, and you can save 67%, and it carries some performance risk as well. So let's actually look at what kind of recommendations you will see in the console. So this is the dashboard you're going to see when you first started Compute Optimizer. There's some new information. These are new launches we just announced earlier this week, and Mariana will talk about it at the later part of the presentation. But the bottom part, Compute Optimizer analyzes EC2 instances, auto-scaling groups, EBS volumes, and Lambda functions. So let's just look at an EC2 instance example. So here, this one is a C5 2X large, and you can actually see there are 3 options here. How to interpret, there are also a bunch of utilization graphs below, and how to interpret these. So, for example, the CPU utilization graph, the blue line shows the current utilization, which is around 20% on average, and then the time range is over past 2 weeks. And then Compute Optimizer try to project the utilization on various options. In this case, the first option is the M5X large, and because it has less vCPUs, the overall CPU utilization would actually increase from about 20% to 40%, which is still within a comfortable range of what the instance can handle. And then the memory utilization, I have a CloudWatch agent installed on this. It's about 81% currently, and M5 XLarge has the same amount of memory as the C5 2X So the memory utilization looks pretty good. Then for network, in and network out, these are pretty low. There's no local storage in C5. And then the EBS utilization is pretty low. So conclusion is that here you can use an M5 XLarge, save you 43.5%, performance risk very low. Every month you're expected to save $106 per month. That's inclusive of any IS and savings plan discounts you may have. And you can actually look at which dimensions are over-provisioned. You can filter this. It only shows you these dimensions can be reduced while still maintaining your performance of the application. So that's an example of EC2 instance recommendations. Let's move on to look at other resource types. So Compute Optimizer also analyzes resource EBS volumes, and in particular, we support SSD volumes here. So there are 4 types of SSD volumes: IO1, IO2, GP2, and GP3. So the main things Compute Optimizer analyzes here are mainly the throughput and IOPS, and here's an example of the EBS volume. So currently you have a 4 terabyte size EBS volume. You provision 20K. Monthly cost is over $1,000. Utilization is pretty low, around like 2,700. And we will recommend you IO1 and IO2. IO2 is actually the next generation of IO1. We don't have storage space utilization metrics here, so we're not going to touch the size of the volume. We're just going to change the provision IOPS, because for the EBS IO1, IO2 volume, you pay for not only the storage size, but also for the provision IOPS. And by reducing provision IOPS, you can actually save about 35% of the cost. So that's kind of EBS example. Let's look at what it shows in the console. Yeah, so here you have IO1, IO2, 20K, reduced to 10K. You have utilizations. There is a spike initially, but we consider it as a kind of anomaly, and we based our recommendations mainly on the utilizations afterwards. So you can see that it's around 27K, and reducing the IOPS by half is pretty comfortable with it. So I've also hear a lot of questions about what is actually the difference between the EBS metrics we analyze for EBS recommendations versus the EBS metrics we analyze for EC2 recommendations. So on the EBS side, on the EC2 side, there are separate limits. So on the EC2 side, it actually limits the total IOPS and EBS bandwidth you can consume at the instance level. An instance may be attached to 1 or 2 or 10 different EBS volumes. So we need to aggregate these EBS metrics and then compare those with instance limits. So on the EBS volume side, we only analyze the metrics for that particular volume. So the recommendations may be slightly different because the type of metrics we analyze for EC2 recommendations, the EBS recommendations are different, and they're totally expected. Now let's look at some Lambda examples. So for Lambda functions, the idea of Lambda function recommendation is that for Lambda functions, you can configure how much memory you use for each invocation. So there's 2 types of Lambda functions broadly. One is kind of CPU intensive ones, so that for the CPU intensive ones, because the allocated CPU resource is proportional to the allocated memory resource. So if your function is very CPU intensive, you can actually allocate more memory to to get more CPU time slices and to reduce your runtime, your execution duration, but the cost of the Lambda function is actually provisioned memory times the duration. Your function is going to run faster, although your memory is larger, the product of these two values stays pretty constant. So you're actually not going to pay much, but you actually get your function running faster. On the other side, there's also functions that are not CPU intensive, another category. Then you provision, if you over provision a memory, you're not going to get any real benefit because you're just wasting these memories. So Compute Optimizer delivers recommendations for these two types of Lambda functions. So let's also look at how it works. Yep, so this is a CPU-intensive Lambda function. Configured memory is 128 megabytes. It's CPU-intensive, which means that the execution duration here is 35 seconds, give or take. Compute Optimizer recommends you to increase the memory size to about 160, although your actual memory utilization is about 40, which is well below the amount you provision. And yet we still recommend you to provision more memory, which seems counterintuitive. But actually, if you look at the projected duration, your function is going to run from 35 seconds to about 28 seconds, which is much faster. And overall, the cost difference of making the change is plus minus 5%. So it's pretty much neutral. So by having your function run faster, you can actually get more performance with very minimal cost difference. So that's a CPU intensive function example. All right, so this is a memory example. You provision 256 megabytes of memory. You only used very little of them, and it's not CPU intensive. We detected that. So if you reduce from 256 to 208, your duration is not going to change. So what happens? You have less memory, duration doesn't change, the overall cost is going down. So here you're going to save about 20% on this function. So these are the type of Lambda functions that we support today. All right, so now we talk about different types of recommendations Compute Optimizer generates. Let's just quickly go through where Compute Optimizer is available. So Compute Optimizer is a regional service, and it's available in 18 different regions, 5 in North America, 5 in Europe, 7 in Asia Pacific, including 2 in AWS China regions, then 1 in South America. And you can access it through Compute Optimizer console, APIs, and through all the other channels that I just talked about in the previous slides. Now let me hand back to Mariana, and she will talk about some very exciting launch we just made earlier this week.
All right, so we're excited to announce some new features to help you discover, review, and adopt Compute Optimizer recommendations more easily. So first, I'd like to say that our roadmap is heavily influenced by your direct feedback. Specifically, we've heard the following tasks over the past several months are challenging. Number 1, identifying which Graviton instances to use. 2, identifying top savings and performance improvement opportunities across the account and resource types. 3, ensuring that recommendations consider monthly and quarterly peaks versus just a 14-day look-back period. So we've heard that you'd like to more easily identify the Graviton resources you should use to maximize cost efficiency while meeting your workload performance requirements. So we listened, and as of August this year, Compute Optimizer generates Graviton recommendations. Compute Optimizer now helps you understand the impact of migrating to Graviton-based instances by recommending up to 3 Graviton-based instances for your x86-based Linux instances. In the existing Compute Optimizer recommendations list view for EC2 instances, you can specify that your preferred architecture is Graviton. And specifying Graviton as the preferred architecture then tells Compute Optimizer to show you recommendations for Graviton-based instance types where applicable. And alongside the recommendations, Compute Optimizer delivers projected price and hardware resource utilization information so that you can easily visualize the price and performance differences you can achieve if you were to migrate to Graviton. So here's a screenshot of the EC2 recommendations list view. And above the recommendations, you can see a drop-down that says CPU architecture preference. And in this case, Graviton has been selected as the preferred option. You can easily toggle between Graviton, between the two options, and you can compare the two architectural preferences to compare recommendations. Here's a screenshot of the detail view, similar to what Letian was showing earlier. And you can choose your architecture preference here as well. And you can do this by toggling between the CPU architecture preferences at the top right of the screen and compare the recommendations for a specific resource. So you also told us that you'd like to more easily pinpoint your top savings and performance improvement opportunities across resources in a workload or account. And we listened to this feedback, and now Compute Optimizer helps you quickly identify and prioritize top optimization opportunities through two new sets of dashboard-level metrics. They are savings opportunity and performance improvement opportunity. Savings opportunity metrics quantify the EC2, EBS, and Lambda monthly savings that you can achieve at the account level, the resource type level, and at the resource level through adopting Compute Optimizer recommendations. You can use these metrics to prioritize and evaluate cost efficiency opportunities, as well as monitor cost efficiency over time. For performance improvement opportunity metrics, those quantify the percentage and count of under-provisioned resources across your account, considering all resource types that we talked about earlier. And you can use these metrics similarly to evaluate and prioritize opportunities that address resource bottleneck risk. So here's a screenshot that shows what the savings opportunity card in the dashboard looks like. Letian briefly showed during his demo. So it comprises two key metrics at the account level. And they're savings percentage and estimated monthly savings. So the percentage of savings you can achieve compared to your monthly cost. It further breaks down monthly savings by resource type. And this supports two main use cases. Number one, Central Infrastructure Manager can easily identify which accounts in the organization have the highest potential savings opportunities so they can prioritize their engagements. Number two, an engineering owner can easily see which resource type has the largest savings to help prioritize the recommendation evaluation. Savings opportunity data considers both the cost of your existing resources as well as your usage, and this data comes from Cost Explorer, so enablement of Cost Explorer is required to see this data in the Compute Optimizer dashboard. Now this is a screenshot of performance improvement opportunity. So it comprises two key metrics at the account level. They are under provision percentage, which is the percentage of resources that Compute Optimizer has found across your account to be under provisioned or at risk of not meeting performance requirements. And also under provision count, which just gives you a sense of scale. So you might have two accounts that have similar under provision percentage, but it might be a difference of 100 resources versus 2. So it helps you better understand that scale. And it further breaks down the count of under provisioned resources at a resource type level and categorizes them based on performance risk. So Compute Optimizer actually calculates an individual performance risk score for each resource dimension. And it does that by looking at the proportion of time over the historical look-back period that capacity might be constrained across those dimensions. Performance improvement opportunity supports two main use cases. Number one, engineering owner can see which resource type has the largest number of under-provisioned resources to help prioritize evaluation. And the second is engineering owner can see which resource across an entire account has the highest performance risk and prioritize our evaluation of that particular resource. So again, helps to reduce the cognitive load and the bandwidth required to identify where the top performance improvement opportunities are. And then the final launch that I'd like to talk about is enhanced infrastructure metrics. So you told us that you wanted Compute Optimizer to consider a longer look-back period so that the recommendations can consider monthly or quarterly peaks, and specifically for EC2 instances and auto-scaling groups. And we listened, and on Monday, Compute Optimizer introduced enhanced infrastructure metrics, which is a new paid feature in Compute Optimizer that you can activate to extend your look-back period from 14 days to 3 months. If you have monthly or quarterly usage patterns, the consideration of the 3-month look-back period can make your recommendations for EC2 instances and auto-scaling groups more accurate and more representative of your workload's characteristics. This feature is inactive by default. So when the feature is inactive, that means that Compute Optimizer looks at the last 14 days of CloudWatch history and generating the recommendations. And in terms of how you can actually activate it, there are actually 3 levels that you can do it at. The first is at the resource level. So in the detailed view that Leighton showed earlier, you can actually activate the feature for that particular resource. The second is at an account level. So as an account owner, in the accounts page, you can actually choose to activate the resource across the feature across all the resources within that particular account for EC2. And then finally, as a management account owner, you can activate the feature across an entire organization. So before concluding, just want to recap a couple of main points that, if nothing else, you walk away from this with. So the first is right-sizing can help you save on resource costs and reduce performance bottleneck risk. And 2, Compute Optimizer can help you quickly identify your top right-sizing opportunities and estimated impact across EC2 instances, auto-scaling groups, Lambda functions, and EBS volumes. This is a link to the Compute Optimizer marketing page with more information and redirect links to our user guide and API reference docs, so on and so forth. And before you go, I'd also like to share some upcoming sessions and resources specifically focused on cost optimization that you may find useful. So the first side of the page is our online resources that you can access to, number 1, Peer Connect, opportunities to connect with peers in the industry to talk about challenges and brainstorm solutions, talk about AWS products together, and these happen regularly, and you can sign up and schedule your attendance. The second is we actually have a cloud financial management kiosk in the expo hall, so please take some time to talk to our experts there. And the final one is the cloud financial management blog. As far as relevant sessions to attend, we have 1 this evening and 2 on Friday. So the first is at 7 p.m. today, Strategic IT Planning and Evaluation. And then the 2 tomorrow, 8 ways to control and manage AWS costs and quantify and maximize your cloud business value. So thank you so much for attending our session. This is great. We will actually conclude here, and Leighton and I will make ourselves available for questions on the floor before the next session comes in. We have some time here, so we'll stick around. Thank you.